Hello, good morning, all. Good morning.
Good morning, sir.
Good morning. So please let me know when I can start. Should we wait for some more time, or we can?
A pleasant morning to one and all present here. The Department of ECE jointly organized a webinar on recent trends in embedded system. I feel honored to welcome our chief guest, Shanmuga Sarathi sir. Now, I welcome our beloved principal, Dr. K. Srinivasan sir, Dr. Ramesh sir, Head of Administrative, Dr. Balakrishnan sir, Head of Academics, Dr. Manju ma'am, Head of IQAC and HOD, faculty members and students. Once again, I welcome you all to this seminar and hope that you will have a great time ahead. Uh, Now, a small introduction about our chief guest. Shanmuga Sardi sir has completed Diploma Triple in 2002. He joined BEC in 2005 at MSAJ Now, he is an embedded system architect consultant. Around 17 years of experience in embedded software and hardware design and development. He has worked in various industries like power system, medical, set-top box, connected car, industrial tool, and worked in companies like HCL, Cisco Systems. He has filed 5 patents. He worked as embedded system architect in Germany for 5 years, a mentor in Startup Incubation Center, and presently being an embedded system consultant. Now, I hand over the session to our honorable chief guest.
Thank you, ma'am. Thanks for a nice introduction. Thank you. Yeah, as already said, I'm Shanmuga Sarthi. I did my BE in AJCE. We were the first batch. We in fact started our college in Padur. Then we literally saw the bricks being laid out for the college that you have right now in Sipcot. And we got passed out in 2005, and I've been working in embedded system for nearly last 17 years in several fields. And recently, like 5 years, I worked in Germany, and now I'm like a consultant doing projects outside. Yeah. Can I get started with the presentation?
Yes, sir.
Yeah, thank you. Can you see my screen? Can you see my screen?
Yes, sir.
Okay, yeah. Yeah, let's define what we'll cover and what we'll not cover. So in this session, we'll try to cover some of the recent trends in embedded system, what they are. So you'll have a broad knowledge of different things, and finally we'll touch base for students what it is really um, required to have for getting into embedded system as a career. And what we cannot cover here is like, so in general, what embedded is and how it is applied in various industries, that we could not cover here because it is being used in almost every industries. That should be like a separate topic. So we'll just cover some important recent trends. And it's not very sophisticated list. I tried my best to capture some of the areas in the time available for me. So let's talk about open source. Open source was not a big famous topic in embedded before, but now every aspect of embedded system is being contributed from the open source communities, like hardware. If you see Arduino or robotics or drone, there are a lot of open source hardwares coming up that anyone can copy and make their own PCBs and also manufacture it. And there are open source bootloaders like U-Boot. Bootloader is the first software that runs in the hardware. Only then we'll invoke our next application or middleware softwares. There are open source bootloaders available, and then RTOS as well. So previously, like 10 years ago, I'd say like RTOS mostly you have to pay and get it. It's all proprietary RTOSs, but right now you have plenty of open source RTOS that we can use it, like FreeRTOS, Zephyr, and also Linux has a real-time version. And there are a few other RTOS, famous RTOS as well, that anyone can freely use it for projects or even for commercial usages. And there are middleware stacks as well, open source stacks, especially for robotics, for a drone, and several other like a router, OpenWRT, set-top boxes, Android stacks are there. There are a lot of stacks available to develop the complete product open source. And libraries. If you name any features, you can find out open source library for it, whether it's a networking or whether it's a file system or it's a database or you're talking about some cryptography or any algorithms, normal simple algorithms. There are well-defined libraries available in the open source communities. So what is the benefit of going to open source? So you don't have to develop everything yourself in the project. So it reduces the project cost and the time as well. So if we do things from scratch, or if we pick up the components from separate sources, small companies and on, then there will be a lot of maintenance phase involved in it, like fixing bugs, modifying it, and integrating to different platforms. But nowadays, all these are addressed by these open source communities. So people take from open source, they use it, they find some improvement areas or find some issues, they fix it, and they contribute back to open source. So that's how this open source is growing. And one major example is Linux. The entire Linux is open source, and Linux is behind everything now, like cloud, even for smaller devices, for set-top boxes, for handheld devices. So Linux has been used right from very small devices up to like a cloud service by Google or by Microsoft, by Amazon. So all of them are using Linux in the cloud, and also Android is based on Linux. Your even macOS has Linux behind it. So that's the power of open source. Yeah, let's talk IoT first. So it's a most favorable, most famous topic for the embedded engineers, because people just start with one Arduino board or on ESP board, and they try to control something at their home. It's a more funful area. it also has a wide industry, and like billions of devices are getting added to the IoT network now. So basically, it involves cloud connectivity. You have a lot of small sensor devices. Those sensor devices are connected to one middle-sized devices like edge devices or a gateway. From there, it gets pushed into the internet to the cloud. But it involves some IoT protocols and wireless protocols. Also, a lot of securities are involved in it because you're passing your data to the internet, and anyone can get into your device, make some security issues in your cameras and your sensors. Also, your device, your data that you push into cloud should be secured enough. So a lot of security protocols are coming up to make sure your data, your devices, from end to end, the chain of trust has been taken care. And this edge computing or gateways are like middle level devices which comes after your sensor nodes, which are a little bit medium sized, which takes a lot of things, which has a network stack, which handles the cloud protocol and device security things. And other feature now, which is famous and embedded right now, is like this firmware upgrade. So previously we used to uh, uh, well define the software after a lot of testings and then put it on the field. If you have to change the software, you go to the field, plug in your debug into the hardware and change the device, or ask the client to ship the device back to your factory. But now it's not the case. So you can sit at your company control center. You can just push the firmware upgrade to the device anywhere, which is sitting anywhere in the world. So it helps things um, to handle very easier. When you find a security bug or when you wanted to add some feature to your product, it makes things very easier. And in the hardware layer, if you see the controllers now, previously we were like talking more about 8-bit controllers, then 16-bit controllers, 32-bit controllers. Now it's like switching, it's transitioning towards multi-core, not just one core in the controller, but it has like two cores at least. The product which chooses multi-core, they at least go for like dual cores if the features are like complicated or involves a lot of challenges, especially when they handle things like security in the product, or when they have some real-time aspect um, in uh, in conjunction with the heavy networking part. They have to put the real time into one core, so it is not disturbed by the networking part. Networking part can have some relaxation, but real time has to be achieved very hard time, more deterministic. So this multi-core is useful when you're building like a medium range or higher range embedded products. And then hypervisors. So hypervisors are, yeah, it's embedded switched from like, it started from a bare metal code. You write some C code, convert into assembly, flash it, and runs. Then they went to C language. Then they went to like C++, and they went to like RTAS. RTAS has a lot of different RTAS, like small RTAS with only scheduler and larger RTAS. Now the trend is put like a two RTAS in the same controller. So one for more secured thing, or just one RTAS and one bare metal thing. So one set of application runs in RTAS, and another set of application runs without RTAS. So both are completely splitted, do not know each other. So like you're installing your one virtual machine in your Windows PC, you can install a Linux virtual machine. So the same concept. Then embedded Linux, yeah. So as I said before, like Linux is more and more popular. It's getting more and more popular. So every day, it also has a good base in embedded world. We call embedded Linux. So they have the Linux as base, but it's like trimmed Linux, and they install drivers for a lot of well-known chips already available in the market for a lot of peripherals, USB peripherals or Ethernet or Bluetooth, you name it, anything, they have a driver for it. So you can go take from the open source Linux, based on your hardware, you can customize it. You can cherry pick what you want. and make your own build out of it. So you're not you're delegating the heavy lifting part to the Linux. So you're not implementing yourself. So you're focusing yourself uh, when you develop product on your application logics. You're not spending too much time in implementing a driver for a chip or integrating that to the RTAS or writing some middleware components. So all of them are very well taken care, and it is being used by a wide range of industries. So those are very well tested. So we need not worry too much about fixing bugs, and we can focus on our business logics. And it is mostly like nowadays this Linux comes with the Yocto build. Yocto is like one build structure, like compilation thing, which can help you to pull different sub repositories, customize it for your own requirement of the product. And embedded Linux is mostly used in major middle range embedded devices or higher range embedded devices like set-top boxes or routers or gateways. Those are mostly with embedded Linux, and it is free. You don't have to pay it. And yeah, system on chip, system on modules, two are a little bit related but different areas. So we started in embedded like 8-bit controllers, 4-bit controllers, 8-bit controllers, and so on. And then they needed a lot of peripherals outside, especially like putting a ADC, putting a USB, putting a um, pulse width modulation or Ethernet. So then the manufacturers, this chip manufacturers, they progress towards next level, like integrating these external peripherals inside the chip itself. Now the chip is a little bit complicated, like it's more bigger, but it solves many other problems for us in a single chip. In previous case, like we need to have one controller and a lot of peripherals around the controller. So integrate all of them with the communication bus and write separate codes for these external peripherals and so on. And now they are coming up with a single chip, especially if you see the set-top boxes or the middle range products, they go for this system on chip, SOC. It's called SOC. So it comes with various set of features, and you would not really need all the features, but we can go and choose something that is more relevant for the project. How much speed you want, what kind of peripherals you want to use, be high speed or full speed, you want Ethernet or not, and you want so many ADC pins or not, and what memory you like to have it inside the SOC, and what communication buses you want from the SOC. So based on all this, we can choose a system on chip, but these are not for like lower end products. These are like at least for the medium end products, the system on chips. And it usually comes with like 200, 300 pins, like a ball grid array package. And it was taking time for the hardware team to design hardware based on this system on chip. So then the next evolution started. It's called system on module. So what the system on module will do is they pick the system on chips, which are most popular, and they put in, they come up with a small PCB that has this very familiar or famous SOCs, and they put the very important peripherals, at least like the DDR memories or like some Ethernet physic chip or PCI on the small PCB. They put all these very mandatory chips, but these are like multiple pins connected. Like these again will come. Every chip will be like 50 pins connected to the ball grid array. Ball grid array is like you have a chip. If you see the bottom, it has small ball like pins, like hundreds of pins, not extending outside like a typical IC. So they do this complex work, and they make it work, and they also give it different variations. Like if you wanted like a 1 giga byte RAM, or if you wanted like 2 GB RAM, or what peripheral USB, or what you want a PCB, PCI Express interface. So they come up with all these things like this in between companies. They get the system on chip from the manufacturer, and they come up with the board that has this very customizable and very critical components put together. And for our development, we can just buy this system on chip, so we don't spend many months of time designing our hardware around this SOC, which are complex. So it's a very fast to market. They also give some basic softwares for the board bring up. Yeah, so that's the benefit with this system on modules. But we have to understand that these are not for low end products. These are basically for medium end or high end products. Yeah, robotics. Robotics drones they are different topics. I just put in a single slide, so it's easy. We don't have too many slides. So robotics has some, as I said, open source. Robotics has some famous open source software for it. It's called ROS, Robot Operating System Framework, and they have a second version which has some sophisticated features from the first version. So it basically includes on OS, and it includes a lot of software libraries and tools. Those are basically needed for the robots. And they came up with a framework, and they open sourced it, and it's very famous for the companies which are involved in the robotics. So if you're developing some robotics, you don't really have to do a lot of millions of coding by yourself. It's already there, and we can write a layer on top of this, like application layer, and based on our product. So it can be a remote car, it can be a robot doing some operation or cleaning. So it can be anything. Those applications we can write on top of this ROS and implement our product. That's the benefit we'll have. And drones also has open source hardware, not only software, because drones involve some like tight controlled hardware and the softwares. So drones has open source hardwares and software. If you have some idea for implementing drones, you can make use of these things. And it involves like the flight control, the software and hardware that is on the drone. For the flight control, your altitude or speed or angle, all the things. And drones are battery managed, so you need a proper battery management system there to handle the battery charging or to control certain parameters in it. And you need a RF protocol for communication from the control station. So they also have defined what are the protocols that you can use. And they also define what you can use in the remote site, like your control station, what kind of software you can use. So it already includes the communication protocol inside it, and you can easily integrate everything together. Yeah. Yeah, then machine learning. Yeah, so machine learning is coming up much faster, and the AI. For embedded, there is famous stack called TensorFlow Lite. TensorFlow is different, and TensorFlow Lite is like a trimmed version of TensorFlow. The processing or the memory resources are very constrained. We have very limited resources. We cannot put like 100 MB code in the embedded system. We need a few hundred kilobytes or few tens of kilobyte code. And RAM as well, we have very limited space of RAM. And the speed of embedded system is like few hundred megahertz. It's not typically in gigahertz. So they have a version for they have this tiny machine learning. It's called TinyML. It's basically a machine learning concept specific for the smaller devices. And this TensorFlow Lite implements that. So if we can use that, it's open source. We can use that. What we can do, we can use it for like computer vision, like analyzing the video, finding out someone's gesture, what hand reaction is doing, or face reaction, or face detection. Also, like for speech recognition, you can train this machine learning modules to recognize someone's voice, or to also understand the languages. Yeah, it's like limitless. It's a broad area in itself. And most of these machine learning stuff softwares are mostly coming up with the Python based thing, because it makes your software development easier. If we do it in C, we have to write like so much lines of code. If you do it in Python, yeah, it's like few lines of code. But Python, of course, it's not highly performance when compared to the C, but still for these kind of heavy lifting or complex things, software development will be easier. So these kind of open source things for machine learning, mostly they are like AI, or they are like Python based. Yeah, the next broad area that is yeah, grooming is autonomous cars, and also the electric vehicles. So both are different. Autonomous cars, so it's like unmanned or self-driving cars. So it has a lot of sensors and cameras around it to detect the objects, to detect the road tracks, uh, and the position. And so a lot of data is being generated in the car now. They need like very strong communication to the internet, and they would not this 3G or 4G may not be sufficient. So 5G is the solution for them to pass such a heavy data to the cloud and process it. Yeah, here you can also think about the concept called edge computing. Edge computing means you're computing the complex parts in the device itself. The cloud computing, you push the data to the cloud, and you let the cloud compute your data and make decisions. But in some cases, we don't have this time relaxations to send the data all the way to cloud, and then cloud instruct us, put a break, there is a man crossing. We don't have that luxury in many applications. So many cases, the data has to be handled in the edge device itself. That's why they call it as edge computing. So here they would need both edge computing as well as cloud based on the case by case use cases. And yeah, artificial intelligence will be a major player. And the stack they use is called adaptive AutoSAR. And previously, automotive industry was sticking to a stack called AutoSAR. Now that is not able to scale to higher applications, and they have come with a new architecture. It's called adaptive AutoSAR, which can hold different, like a huge complex task, data also, which is scalable. Yeah, so these are about autonomous cars. And then the cars in the automotive, other interesting field is electric vehicles that you'd know. So now we will no longer need the diesel or petrol engines. It's all going to be operated by motors, and behind it we're going to have like series arrays of batteries, and that needs a very sophisticated battery management system. So here the major things are like motor electronics, how it's going to be controlled, and how we control the batteries charging and discharging, and the heat or other issues from batteries. So these are the major areas in the EV cars segment. And yeah, let's slide down to smaller piece. And not to miss, we have these small devices are coming up as well so much, especially this wearable devices or small sensor oriented devices, which runs in a small battery, but it has to give a long life, maximum usage. I mean, most optimized usage. This area is little different. And here you have a small battery, lithium polymer, or a small coin cell battery, if lucky, a lithium ion battery. and we have to design the hardware in such a way that every chip you put in consumes very lower current, like microamps, or you are able to switch off the devices when you don't use it. The software you run is also like taking care of the power management. It doesn't drain too much of power. It only consumes as minimal as required to accomplish the task. Yeah, the smart watches you have, or like all other small handheld devices, you see the power on the payment machines, or a lot of other sensor oriented devices, these thermometers. So all these are yeah, low power devices. Yeah, and then in a broad scope, not sticking to one domain, uh, industry needs a lot of security improvements and experts, because now we are generating a lot of data with all this advancement and new sensors and cloud connectivity, and user data are involved, payment informations or security passwords. So a lot of things are involved, and this security concept actually starts right from the hardware. It's called root of trust or chain of trust. It has to start from the hardware and end to end. Nowhere we can have a relaxation, so then it breaks the complete system. So there are a lot of things right from the hardware. You would have heard about ARM Trust Zone. ARM architecture has a concept called Trust Zone. This sort of software runs in a very trusted mode, which normal software cannot access. And a lot of encryption mechanisms in the communications. And for even now, embedded devices are communicating to the internet, so it is integrating the TCP/IP stack. So they also need this transport layer security. It's called TLS. A lot of keys handling, private keys, public keys, sharing, and certifying the other devices it communicates to. So all these things are involved in the security areas. This is very broad. It applies to any industries in embedded. And other area is functional safety. Same way. Security is handling your data safely. Functional safety is making sure the device does not harm the user or the environment. So if you see aerospace, medical, those are like highly life critical. Any small bug can make a huge loss of life or loss of properties. So we have to do it right from the software or hardware, make sure every small component works better, and they are fault tolerant. If there is a fault, that is able to be managed. In the automotive industry as well, it's a big topic, because in the car, if you take a car, it has like few hundred small boards within the car itself, and they are interfaced like thousands of wires and buses in the called harness. So these industries needs not only this, but also other industrial products or whichever involves user safety. They are there are standards for this to be taken care. So you have to be complied with those standards in the end to say that your product is functional safe. So they are taking care of this in the hardware or software testing and everywhere to make sure your product does not cause any human life. It's not just implementing something and showing that it works. So it also has to take care of security. Your product also has to take care of the safety concerns of the people on the system. These are very common topics for the entire industry. Then yeah, then other advancements are like now uh, the repositories, the source control repositories. You would have heard about GitHub. I recommend you go and please have some hands-on in the GitHub, have your own user account, write some program, push it to your own repository. Yeah, this is what the companies are using, and now they have gone to the next level. Like when you write the code and when you push it to the repository, then they make a line like integration, like this code will be pulled in, and they make one build like every day or weekly once, like compiling an image. And that image they give it to a testing department or to automated testing, and they run some automated test cases on the image to make sure the work you did last week does not break anything, also completes the feature that you intended to complete. So it's called continuous integration or continuous deployment. So this is also, it was there already in other industries, but now embedded is also using it so much because it's helping to reduce the time, also to find out the bugs yearly. Also automated testing, a lot of automated test benches are coming up, like so the previous example explained. So in one phase is like after you build the image, that will be automatically flashed into a board, and some python script or scripts will be run to test the image. They see the output with a lot of sensor. They make one hardware itself, special hardware, to test your software, and it gives some specified input and it checks whether you're getting a desired output or not. So the automated testing is also grooming well. And model based development, some of the things like electrical or more like mechanical oriented. So they have like even before you jump to the coding or design, they first make some models, pull different components, make one model, and run a simulation and make sure your concept works. So they do this with MATLAB, especially for battery management or the windmills or other this electrical concepts or mechanical concept which are integrated to electronics. And LabVIEW as well, yeah, for testing environments, to come up with a model-based testing environments. Yeah, so those are like some heads up in different areas. And this slide, I would say, is more important for the students. So having talked about all this, you can ask me, so what is most important for you if you are interested to get into embedded? So what is really good to have, what the industry expects from you? So industry does not expect from you like in-depth knowledge, but it expects you to have some basic knowledge in the electronics, to understand what is ADC, understand what is UART, what is analog signal, what is digital signal, what are the different protocols, I2C, SPI involved, what it means filters. You need not say you connect this op amp, you put so and so capacitor and resistor, you reach. You need not have such level of things now, but at least understand there is a filter involved, what kind of filter involved. And then microcontroller. So microcontroller, what kind of microcontrollers are there? 8-bit, 16-bit, 32-bit. What things are usually inside microcontroller? Some basics like the speed of it, what a cache memory, or what is like a internal RAM or the internal UART. So all these basics, the pipelines, and C programming for sure, must one, and C++ as well. And C++ has gone to a great level now, like 10, 14, 17, 20, 21. But you need not have such level thing, but at least have like choose one middle version and have some good knowledge, strong knowledge in OOPS concept, and have some basic exposure at least to the middle version of the protocol the C++ has. And for sure, RTOS basics. So what is RTOS? So what is a thread? What is a task? How does this task, this thread talk to each other? IPC mechanisms, semaphore, mutex, message queue, some basics. So these are all good to have. The basics are good to have, and it will be really nice. You guys, nowadays we have these Arduino boards and ESP boards very casually available in the shops or online shops, and especially the code that you want to develop is also available openly. A lot of YouTube videos are there. I would say everyone, please grab at least one Arduino or USB with you. Keep one with you. Try out some code. You need not do everything yourself. At least do just copy and paste it to start with. First, get on board, bring it up, copy and paste. See LED is glowing. It's like step by step, like a baby walking. So see LED is glowing. It's hello world. Then you go to the next level. Just initially copy and paste. Then you start making something yourself. I think this is very important to bridge this academics to the industry. And now it's very openly available, so we can for sure do it at the simple cost involved and simple resources involved. Everyone has a laptop, so don't really need any huge laboratory or things for it. Yeah, and there are a lot of topics involved in embedded, like medical industry, automotive. So if you have any interested area, you can surely go in deep into it. but these basics are important for anyone who wants to come in. And the industry that you go in, like, is the next topic. And if you're right now itself, you're sure this is what I want to go, you can jump into the industry. I mean, those specific projects involved in that area, like I want to build one IoT product, I want to control my home light or fan at least, or I want to build one small robot. Yeah, if you have so much interest in one area, yeah, please try it out. There are open source things, there are articles already published how to set it up step by step. Yeah, and then I would say it's so much vast, then you may be confused what to do. So I would say uh, try to know something about everything. Like a lot of topics that you hear, you just note down, try to know something what it is. So if somebody if you have to think or speak about it, like you can speak for 2 minutes at least, you know what it is. When you're connecting small dots, when you work or in your own projects, so you know what dots you should connect when you know something about everything. And if you really like something, then go in deep into it, know everything about something. You chose one thing, you say you're an expert in it, try to know, go to the depth, don't be sitting on the surface. But at the same time, try to know most of the other things, small other stuffs, what it is, at least know what it is. You need not know how it works at the first stage, but at least what it is. Yeah. And this electronics is so much broad. So anything in your home you see, most of the things are electronics oriented. You will need electronics to realize a product, for mechanical product or for software or for anything. Finally, if it has to be realized into one product, it needs electronics. So electronics is everywhere. Electronics is there in your car, in your two-wheeler, in your electric meter when you go into a house, then the camera and the device behind the camera, which is storing the records, which is pushing to the your network. And then your calling bell, your fridge, washing machine, your microwave oven, or your induction stove, or a TV, Android TV set-top box. And we are using satellite every day. The set-top box, it's actually your antenna is connected to. It's receiving signals from the satellite, and the satellite itself is electronics device. So then the fans, BLDC fan with the remote, and the Wi-Fi router. So everything you see one way or other way is uh, that is electronics, mobile charger or mobile phone. So it's a very good industry. We can solve a lot of problems with electronics. Yeah. So, and we know the basics. The one advantage with electronics and communication engineering is you can either go in electronics embedded side, or you can also go in software side. Advantage is if you go into software side, you can really understand the basics. You know how it works in the core level, what a cache is, what a DRAM is, what a flash memory is, how it is linked, what a speed is, which typical high level person who is getting into software may not understand. So we can understand all these concepts right from the root. That's the advantage we have. Yeah, that's all I would like to say. And now it's Q&A. Please, if you have any thing to check, please put it forward now. We can talk. Any questions, please feel free to ask. I do not know everything, but if I know it, I can explain. Yeah, Girish, please. Yeah.
Yes, sir. Good morning, sir. It's been a warm thing speaking with you, sir. I'm listening to your wordings. Hello, am I audible to you?
Yeah,
sir?
you're audible. You're welcome. Yeah, please.
Yeah. Actually, it has motivated me a bit in both choosing VLSI and as well as embedded systems. But as a layman, can I don't know if it's appropriate to ask this question. Which space more? Is it VLSI or like embedded systems?
Yeah, it's more specific to your interest. I would not. I could not really say you that you choose one because it's more related to what your interest or what would match your core thing is. But
Yeah.
nothing like I would say nothing is like better than other. Uh, but embedded is like more broad. Embedded is very
Yes.
broad. You have like 10 industries at least. You can do coding for that skills that I explained. If you are good in that, you can actually go and start write coding for those 10 products. VLSI is one more specific area, one more specialized area. Embedded is very broad area. So VLSI, you have to do at least some masters and yeah, go into it. And for embedded, you really don't need a masters. I would say bachelor's is more than enough, and then practical experience. Yeah, it's then I'd say you try to explore a little more. In my knowledge, that is more specialized and this is more broad. I would not say one is super better than other.
Okay. Actually, sorry for interrupting, but before listening to your words, I was more into VLSI. But after listening to this seminar or webinar, I am more interested into embedded systems itself. Maybe it got into me more than VLSI after listening to your words.
Yeah, you start exploring, Girish. You please spend some more time. You'll explore a little bit more.
For
And,
sure.
right. You can also do some projects. Initially, you can start. You can work in some projects. You get some more better. Let's say better realistic idea about what it is.
Yes, sir. Thank you, sir.
Yeah, welcome. Yeah. Bashrat is asking, is there any software to simulate the ESP board? I'm not sure, Bashrat, but yeah, I think some of the IDEs you can do that. But ISP board itself is very commonly available. You can very usually get one and start doing it. But some of the IDEs, yeah, I guess it can support. And then what Ahmad Said Samar, what are the main security concerns for embedded in the area of IoT and connected devices? Yeah, security concerns is now the devices are connected to internet. At least they are connected to some Wi-Fi or Bluetooth devices outside. Previously, it was not the case, but now we are connecting the device to outside. So your data is going outside. So we want to make sure your data is not being misused. And second area is you're not letting somebody to access your device from the internet. So we need a very secured communication when your device is connecting to the outside world. By that, you're making sure somebody cannot get into your device. So you're using encryption or TLS, and for it, you will have your own private key and public key inside it. You will have an open SSL or crypto engine inside it. And other part is securing your device. Somebody cannot just put on debug connected to your hardware and read the keys you stored in it, or write their image on top of your image. So this write protection, read protection, tamper protection. So all those are in the both side, and somebody cannot just like that flash their image. The image has to be signed, the image has to be encrypted, and that will be verified by the bootloader. Only then their image can get into the board and run. So by these mechanisms, we ensure in IoT that security is taken care of. Yeah. Then the Shahrukh Fakhruddin. First of all, thank you for. Yeah, sensors are really playing a major role, especially in the end, in the tail part of the IoT, which are collecting the data. You should have seen some ad from Robert Bosch. They're showing a very a small sensor. It's like the size of your urud dal. It's for making sure the air quality. So it is doing all the air quality, like the temperature, humidity, pressure, the moisture, and the pollution. It's just one small device, and it will usually be connected through I2C or SPI to the controller. Those sensors are also really evolving. Those are really needed for IoT, and then many new area sensors are coming up. For everything you say, there is already sensors, but some areas the prices of sensors are really very high. If you go to this electromagnetic front end, where you have to find out like a microamps or microvolt from electronic conductivity sensor, those are a little bit expensive, but yeah, there are sensors for every cases that we need, and those are really helping for the embedded system to collect data for different cases, chemical detection, gas, and a lot of things. Amudishwaran. Yeah, power management, it goes one side in the hardware side. So hardware chip that you select, the circuit that you put, you have to select the low powered, low current consuming devices. It's called quiescent current. Even when it is not functioning, it should only draw like microampere of current. So in hardware, we make sure we do that, and we put some switches so we can switch off some of the switches. Is not the sense manual switches, but the electronics, this digital or analog switches. You can switch off some of the subsystem, the hardware that we don't use it. And in the software, we will have like a lot of power modes. So we have like standby modes or power save modes or fully run. So you switch the software across different modes, and you have very small timeout. You would have seen your watch. So it goes to different modes, and it just switches off so quickly after you see it. So a lot of things are there in the software as well to make sure the software is not consuming too much power, and you're going to standby mode as soon as you're done with your job. And it only periodically works, periodically wakes up, it does operation, then it goes and sleep. So by those mechanisms, we make sure that we use the battery sensibly. And Girish. Yeah, the same reason. Yeah, same as above. Power, energy efficiency. Yeah, starts from hardware and then the software. Hardware provides the modes as well for the software to enable. So your chip clock speed will be brought down when it is not actively working, and you can switch the modes based on the software functionality you're doing. When you're communicating to Bluetooth, you will enable one mode. When you're only reading a sensor, you will enable one mode. If you're not doing anything at all, you'll go to a sleep mode. So with the help of those modes, we make sure we don't take more power from the battery. This we spoke. Embedded and VLSI is very specialized area. Embedded is a very broad area. To answer, to cut short a long story, that's what I would like to say. Madi, what are the challenges, opportunity in recent embedded system, practical application, our researchers addressing them? Yeah, challenges mostly are security things, and then this power management, because a lot of things are coming into embedded, and some of the cases we are battery managed. How do we handle those cases with the battery thing? So security, this power management. Other is embedded is always like a resource constrained device. So it has like few KB of RAM, few KB of flash memory, and but the product requirements are so high. They wanted to implement everything on a single board, and developers really have like a very high challenges to handle this, implement a huge functionality in a very resource constraint. This complete development, software development is, you have to think differently to make it work. Not like in a typical software, well, you implement it, you put extra resource, it's fine. As long as it works nice, they accept it. But in embedded, it has to work nice, as well as it has to only consume less power or less CPU cycles. So those are all the challenges. Mohammed Mukshid, how is edge computing being utilized in embedded system to improve system performance, reduce latency? Yeah, as I explained, so we cannot, so now the cloud connectivity is there in IoT. We are pushing the data to cloud, and we are having this heavy data computing stuffs in the cloud, but it involves some latency and speed. In some cases, as I explained, like autonomous cars or robotics, you don't have that luxury to wait for cloud to react, and you will depend on the 4G connectivity. So most of the cases of these areas, you need to do the stuff in the edge computing itself. For that, your board should be, your hardware should be capable enough to accommodate those libraries to run itself in the edge device itself. It should be speed. It should have enough memories, all the resources, and by that way you make sure that you make the decisions in the edge computing itself. You don't depend on the cloud. Later you push to cloud whatever you wanted when you have time. Yeah, I think that's all for now.
Thank you, sir, for your wonderful and deep explanation for our queries. It's my privilege to propose a vote of thanks on this occasion. On behalf of the department, once again I thank our principal, Dr. K. Srinivasan, sir, Dr. Ramesh, sir, Head of Administrative, Dr. Balakrishnan, sir, Head of Academics, Dr. Manju, ma'am, Head of IQAC and HOD, faculty members, and students. Embedded systems are not only one of the most important field for current computer-based application, it is also one of the most challenging field of software engineering. Thank you for your explanation for basic skills required in embedded system. The seminar was truly worthy, sir. You really motivated us to gain more knowledge and work hard in our respective fields. Once again, I thank you one and all present here and actively participated in this seminar. Thank you, sir.
Yeah, thank you so much. Thanks for this opportunity, and I'm really feel happy to contribute something back to my college. And thank you, Mr. Ramesh, and HOD and everyone, the students who patiently listen to. And I wish you all the best. Thank you.